Okay, now we are back. We're doing the second example, and you'll notice it only has 4 parts, A, B, C, and D. Again, we're giving exact simplified answers and then approximate answers rounded to the nearest tenth. And I'm thinking that maybe for the last problem, did I forget to give approximate answers? Actually, we didn't have any radicals, I guess, so we're good. Just sometimes we get more complicated answers that have radicals in them. Let's see what happens on number 2. Okay, an arrow is fired upward with an initial velocity of 30 meters per second from the bottom of an old well 15 meters below the ground. When will it reach the surface? When will it be 30 meters above the surface? What is its velocity at 2 seconds? And how high is it the first time its velocity is 0? So notice that we're working in meters this time. So the equations we want to use are S of t equals negative 4.9 t squared plus v naught t plus s naught, and v of t equals negative 9.8 t plus v naught. And we're told our initial velocity is 30, and it's upward, so that's positive 30. So we have S of t equals negative 4.9 t squared plus 30t, and we're told that the initial height is 15 meters below ground, so I'm going to think of that as negative 15. And then here's our velocity equation. Velocity equals negative 9.8 t plus 30. Okay, when will it reach the surface? So when they say when, we're going to find the time, so solve for t, and the surface would be height 0. So we want the position S of t to be 0. So let's put 0 in that equation for S of t. Okay, to solve this equation, just like we saw in problem number 1, it's not very user-friendly, so let's go ahead and use the quadratic formula. So we have t equals the opposite of b over 2a plus or minus the square root of b squared minus 4ac over 2a. Okay, to simplify negative 30 over negative 9.8, first of all, we could cancel the negatives, and then we could also think of it as 300 over 98 if we multiply the top and the bottom by 10. That way we don't have a decimal, because when you have a fraction and you're trying to simplify it, you shouldn't have a decimal inside the fraction. And then both of these numbers are going to be divisible by 2, so we have 150 over 49. And I think that's about as far as we can go with that. And then let's find our discriminant. So we have 900 minus 4 times negative 4.9 times negative 15. We'll be real careful with our negatives there. So we get 606 for the discriminant. Now let's think about this for a minute. If you have plus or minus a negative, it's the same thing as plus or minus a positive, because plus a negative is minus, minus a negative is plus. So we can actually just write this as 150 over 49 plus or minus square root 606 over 9.8. So if you see that little negative sign missing, don't think it was a mistake. It was purposeful. It simplifies to be the same thing. 606. Okay, let's see if we can simplify the radical. So are there any perfect squares that divide into 606? It's definitely not looking like it, but what I want to do is get rid of the decimal in that second fraction, so I'm going to multiply it by 10 over 10 as well. And then let's evaluate both of these answers to see if they both make sense. When will it reach the surface? Okay, so we have 2 answers. Now let's think about the path of the arrow. So here's the ground. There's a well. And the arrow goes out and comes back down. So there's 2 times when it's at the surface level. When it's coming up and when it's going back down. So those must be our 2 times. Let's go ahead and approximate these with a calculator and round to the nearest tenth. Now, first of all, you're probably asking me, Mrs. Zimmers, why are you not reducing that second fraction? You're right. I just didn't see that at first, so I'm going to reduce that. Put these in the calculator, and we get approximately 0.5 seconds and 5.6 seconds. So it took about half a second to reach the surface the first time, and then when it made it back down, it was at 5.6 seconds, approximately. And then we have our exact answers as well. Let's take a look at part B. When will it be 30 meters above the surface? Okay, so we're doing essentially the same thing, except instead of putting in a 0 for S of t, we're putting a 30 for S of t. Oops, how'd I get so many equal signs? I don't think today's my day for accuracy. Okay, so how about if we subtract 30 from both sides? And then once again, just use the quadratic formula. So t equals the opposite of b over 2a, and look, that's going to be the same thing each and every time. Oh, there we go again. Plus or minus the square root of 900 minus 4 times negative 4.9 times negative 45 over negative 9.8. Now before I go too far, I'm curious about that discriminant, so I'm going to calculate it next. 900 minus 4 times negative 4.9 times negative 45. I was just curious if that was going to turn out to be negative, because that would mean if our discriminant is negative, we would have the square root of a negative, and that would mean it doesn't actually reach that height. But it turned out to be 18, and so it's positive, so we can keep going. And remember, this first fraction we saw in part A is just going to simplify to be 150/49. And then we have plus or minus square root 18 over, and I'm going to eliminate that negative again, simplifying. And square root 18 can be written as 3 square root 2. So suppose I do that and multiply the top and the bottom of that second fraction by 10. So that's going to be 30 square root 2 over 98. And that fraction reduces. Divide the top and bottom by 2, and we get 15 square root 2 over 49 for the second part of that answer. So let's go ahead and approximate putting those into the calculator. And for those we get approximately 2.6 seconds and 3.5 seconds. Okay, let's see what we need to do for part C. What is its velocity at 2 seconds? So let's use that velocity equation. V of t equals negative 9.8 t plus 30, and substitute a 2 in there. And what are we expecting? Are we expecting that it's on its way up at time 2 or on its way down? If you think about the last part of the problem we did, part B, we noticed that it had reached a height of 30 at time 2.6, so that must have been when it was on its way up, and a height of 30 at time 3.5 when it was on its way down. So then at time 2, it's still on its way up, so we're expecting a positive here, and we get positive 10.4. Okay, now for part D, how high is it the first time its velocity is 0? So let's imagine this situation again. So here comes the arrow out of the well. It has a positive velocity when it's moving up, and it has a negative velocity when it's moving down. So right there at the top, it has a velocity of 0, right at that moment when it's at its peak. And it is at its peak when it's at its vertex, and the time that it would be at its vertex would be the x-coordinate of the vertex. The x-coordinate of the vertex opposite of b over 2a, we have already found earlier in the problem to be 150/49. So what we want to do is find the height at that time. We want the y-coordinate of the vertex. And we know to get the y-coordinate of the vertex, we take that x value and we substitute it into our position equation. And I'm going to go ahead and put this into my calculator. As fun as it might be to work out the fractions, I know my videos are running kind of long today, so we need to cut some time where we can. So I'm going to put this in the calculator but still get the exact answer. And I got 15 49ths. Let's change that to a mixed number just to have a better feel for what height that is. So we get 30. Let me figure out what that rest of it is, that remainder. Let's see. Oops. 30 times 49, 1470, 45. Okay, so I'm thinking we have 30 and 45 49ths as the height, so that would be meters, and the approximate value of that is 30.9 meters. That's the highest point. Ooh, so when we were asked earlier in part B, when will it be 30 meters above the surface, we were very close to that actual highest point, weren't we? Okay. So there you go. You've seen a couple of physics problems, quite a lot of detail. I'm giving you a physics application worksheet which has 3 problems on it. And as you saw with the notes, today we're taking an algebraic approach. And what I want to do tomorrow is kind of revisit these same problems, but showing you an approximating approach using your graphing calculator. Thanks, everybody.